everyone. So we're going to continue on with exercise 12C. So we're looking at our transition matrices. And just like we did in finance, we can use recurrence relations with matrices. Okay? So we can either do things recursively, like work out day 1 or week 1 and then do week 2 and then do week 3 and then do week 4 one at a time till we get to where we want to go. Or just like we did in finance, we can use a rule. So you have to be really clear on the two differences. And I know some of you had trouble with this when we were doing finance. Okay, so I'm trying to stress it here. There are two ways of doing this. The first way is recursively, one at a time, and the other way is just using the rule to find the number that you want. Alright, I'll go through and explain what I'm talking about. Think back to the other day and we looked at a car rental problem. And this car dealership had two offices, one in Bendigo and one in Colac. Now, we're going to start off by looking at this recursively. So let's say that the Colac branch has 50 cars, the Bendigo branch has 50 cars actually, and the Colac branch has 40 cars. How many cars will there be at the end of week 1? Okay, so what we're going to do is we're going to find S1. To find S1, we'll take our transition matrix and we're going to multiply it by our initial matrix. And just like in finance, the initial matrix was your principal. With your matrices, your initial matrices are, well, how much is there at the start? So we've just said 50 in Bendigo, 50, 40 in Colac. Okay, so that becomes my initial state matrix, my SO. It's the same as my VO when we did finance. Okay? And I've got my transition matrix, which is the one that we worked out in our last lesson. 0.8, 0.2, 0.1 and 0.9. Okay, so if I want to find out how many cars are going to be at each location at the end of the first week, and I'm doing this recursively, I say, okay, so S1 will equal my transition matrix multiplied by my initial state matrix. So I do that multiplication and I find the answer is 44 in Bendigo and 46 in Colac. So less end up in Bendigo, more end up in Colac. Okay, so after week 2, so for S2, I'll need my transition matrix and the answer for S1. So I take my transition matrix and I multiply it by the answer from S1. And S2 equals 39.8 and 50.2. Did we talk about 39.8 cars? No, we don't. So, of course, we're going to state our answer because this is working out. Your matrix is your working out. So the answer is going to be 39.8. Well, that will round up to 40. So there are 40 cars in Bendigo and 50 in Colac. With rounding, always make sure you don't lose a car or gain a car. For example, if that had have been 39.5 and 50.5, one would have to go up and one would have to go down. Otherwise, we're going to end up, if we put them both up, we're going to end up with an extra car. We can't do that. And that's okay. Just decide which way you're going to go. It doesn't matter. You won't lose marks because it's going to show in your working out what you've done. All right? But in this case, we round to 40 and 50, and that means I still have 90 cars, which is the number of cars I started with. That's all good and fine until I want to find, well, what happens after week 10? I don't want to be doing that, one after the other, after the other, after the other. I mean, what if you said to me, well, what happens after week 20? I'd be there all day. So we can use the rule. Now, remember with rules, we have the power of n. So the rule is Sn is equal to the transition matrix raised to the power of n multiplied by the initial state matrix. So let's have a look at a different problem. Let's say we have a factory. The factory has a large number of machines. The machines are either operating, working, or they're broken. Broken machines get fixed. Working machines break down. Okay, so this is the transition matrix of how they move in and out. They're either working or they're broken. Okay, so we start off with 80 machines working and 20 of them broken. And this is the transition matrix that we're given. Some questions you'll be given it, some questions you'll be given a diagram, some questions you'll just be given statements and you'll have to use those. In this particular question, we've got a transition matrix. So, I want to know, after day 1, this would be doing it recursively. What's going to happen? So S1 is equal to the transition matrix multiplied by SO, and I find out that I've got 69 machines working and 31 machines broken. So after the second day, so S2 would equal to T, the transition matrix, multiplied by the answer from S1. And I get that I've got 53.16 and 46.84, which means I've got 53 working and 46 broken, because we don't talk about point whatever of something. Alright, but what happens if I want to know after 10 days? What I would do is, of course, I've got my transition matrix entered into my calculator and I've called it T. And I've got my steady state matrix entered. I might have called that S. So what I say in the calculator is I take T and I raise it to the power of 10 and I multiply it by S. Okay, so this is purely done on the CAS. And when I do that, I find out that I've got 30.9056 and I've got 69.0944. So we do our rounding. I've got 31 that are working and I've got 69 that are broken. And a quick check tells me my rounding is okay. I haven't gained a machine or lost a machine. Lucky for me. Okay, I've still got the right number of machines there. So that's the way we use the rule. We do it on the CAS and it's just raising the power. So when you name your matrix, you call it matrix A. You'd say A raised to the power of whichever particular number you're looking for. Okay? If you need any help with that, you can talk to me about it when we're on WebEx, and I'll try and explain it again on how to raise it to the power. Now, the other thing we need to consider is steady state. So we've got this idea of this rule thing happening. So if we think back to our car rental problem, we've got cars going up in Colac. The number of cars that are appearing in Colac seems to be going up, and the number of cars that are in Bendigo seems to be decreasing. Now that could be a problem. The owner of the company might want to know, is that going to continue? Are all my cars going to end up at Colac? Or are we going to reach a point where the number of cars going to Colac and the number of cars coming back to Bendigo balance out? We reach what's called a steady state or an equilibrium. Now, with steady state, you must find two consecutive matrices that are exactly the same. And the rule I'm going to give you is raise your T matrix to the power of 100 and 101. Write down the two matrix and see if the numbers are identical. Okay? That will tell you what the steady state matrix is. That's all you need to do for steady state, is you're usually trying to find the numbers where it's going to be steady. If you have to go beyond 100 and 101, there's something wrong, okay? So always use t to 100, t to 101 to find what your steady state matrix is. All right. If there are any questions about that, I'll chat to you in WebEx. Okay, guys. See ya.